Okay. So I'm going to bring up the so like I said before, today we're going to see automation in AWS. Okay. The ultimate goal of every architect, any developer, any DevOps engineer, the ultimate goal is to automate things. Okay, more than anything. You don't want to do anything manual. Okay, manual things, they are less perfect than automated. Okay, because whenever you have humans, I mean, humans are nice people, right? We're humans, right? We have to defend our race, our species. But whenever you have humans, things are prone to fail, right? Because it's not perfect. Systems, when they are well configured and well set, they work better than humans. So the objective of all DevOps engineers, all architects, is to be able to automate every single thing in AWS. So you don't have to worry about that. And that's one of the advantages and benefits of AWS, that you don't have to worry about this, machinery. And instead, you can focus on something else that is more important for your business. Okay. So this chapter, this module is super important, especially from the architecting standpoint, because you can make things work, by themselves, and you don't have to worry about anything in between, unless there is any manual step that uh, you have to implement, just in case. For example, you have a pipeline where there's a series of steps. So, for example, you have to um, build the code, deploy the code, but probably in between building and deploying, you have like a manual step where the administrator or the developer, the lead developer, gets a notification that there's a manual step that they have to review before the code goes on to the deployment, right? So this guy has to come and manually approve that build of the code, right? So he has to review the code. Maybe it's one guy or the group of three, a group of three developers, some people. So they check the code, they see that everything is it's fine, then they approve it, and then the code goes to deployment and is deployed. Okay. So, but everything else is automated. Okay, should be automated, except for the manual approvals. Okay. So the part one is manual environment configuration. Part two is infrastructure as a code on AWS. Whenever you hear infrastructure as a code, that's Cloudformation. Okay, Cloudformation, right? Grouping resources in the template. Okay, we're gonna see a template in Cloudformation. Don't panic when you see that. It's just a matter of getting used to, right? Resources not supported by AWS Cloudformation. There are some resources that are not supported by Cloudformation, and then you have to create something called custom resource, and then that will be done by Cloudformation. Okay, Lab 5, we're gonna talk about that later. Okay, actually, it's Lab 5 today. Okay, sometimes the numbers don't match. All right. So upon completion of this module, you will be able to articulate the importance of making systems highly cohesive and loosely coupled. When it says loosely coupled, can you tell me what this means? Loosely coupled?
Not dependent on one another.
Correct. When you hear tightly coupled, that's the opposite, right? They're depending on each other. Loosely coupled is they're independent. They're self-contained, right? So recall the multi-dimensional facets of system coupling to support the distributed nature of the applications that are being constructed for the cloud. Okay, manual configuration. Here you have creating and configuring AWS resources, services and resources through a management console is a manual process. Okay, So can you imagine if you have to, I don't know, you have to create 25 servers, you have to create 20 Lambda functions, you have to create an API gateway or several API gateways, you have to create several tables. Imagine you have to do all that manual, that's gonna be a pain in the neck. So a manual process is all done in the console, right? It's all done in the console. Even the CLI, it's manual. But you can create some configurations. You can create an auto scaling group in the CLI, right? And after that moment, after that manual moment, when you create the auto scaling group, everything else is going to be automated, right? But even the CLI, it's at a certain point, manual. Manual processes take time, they take resources, they take people, they take money, right? So because the more people you need, the more money you have to spend, right? But when you have things that are automated, you can save tons of money, right? So what are the challenges of concerns for a manual process? Reliability, right? You know, unfortunately, humans are not as reliable as programs and systems. Systems are more reliable because it's something that even humans create, but when they are operational, when they work, they are less prone to fail than a person. Okay, reproducibility, right? Dev, test, prod, documentation, right? There's a lot of documentation for, especially for automation, more than anything, right? And for manual processes, there's documentation, but that might be a challenge, right? That might be a challenge. Because everybody's is just moving towards automation more than anything, right? So there's more automation, documentation automation than manual processes. Okay, so here we have the anti-pattern and the best pattern. So where possible, you automate the provisioning, termination, and for configuration of resources, right? This where possible. There's some instances when you need manual processes. Like I said before, sometimes you need an approval by a manager. So you need a manual process. But when possible and where possible, always automate your infrastructure. Okay. So the anti-pattern here, we have an application server crashes. The users cannot access this server. Okay. So the administration has to come here and manually configure servers. Okay. Then the users, they have to manually notify the admin, like send like open a ticket or something. And then this guy will come here and manually configure as a server. If it is one, it's okay. Can you imagine if you have to configure 100 servers? That's going to be really, really painful. So what is the best pattern, right? So you can improve your system and make it stable and consistent as well as efficient by removing the manual process, okay? We're trying, at any cost, we are trying to avoid manual processes, okay? As an architect, that's our ultimate goal. Forget about manual. We need to automate, okay? We need to automate. And in this best practice, we have an application server. It crashes, but we have CloudWatch, right? CloudWatch that it detects that this instance is not healthy anymore. So what CloudWatch is going to do is going to both notify the administrator and, trigger auto scaling. Okay. And then we're going to launch identical servers, because what auto scaling does, it creates instances that are the same. All of them are identical. They have the same configuration. Remember, when you create an auto scaling group, I don't know, I'm saying remember, I don't know if you know it or not, but when you create an auto scaling group, the first step is you have to create a configuration, okay? A configuration. If you come to the AWS console, right? Let me open here real quick. It's called the AWS console. So if we create here an auto scaling group, right here, auto scaling group. If you click on it, create auto scaling group. So the first thing that we have to do is launch a configuration, right? But we don't have any configuration, right? We have to create a new one. So that's the first step to create an auto scaling group. Create a launch configuration. And a launch configuration is basically the EC2 instance. But auto scaling is gonna use this configuration to create identical servers when they need to scale out. Okay. So that's basically what auto scaling does. Okay. And that's going to be triggered by CloudWatch. Okay. CloudWatch is possibly the most important service for automation, CloudWatch. So keep an eye on this guy on CloudWatch, because that is a tough guy. Okay. That's a tough guy. It's going to be wherever you go, CloudWatch is going to go with you. Okay. Wherever you go. CloudWatch, S3, SQS, those services are going to be with you all the time. Okay, for automation. When automation, you're going to have Cloudformation as well. So the best practice is what you see here. Anti-pattern is what you see on the left-hand side. The best practice is on the right-hand side. Disposable resources. Take advantage of the dynamically provisioned nature of cloud computing. So anti-pattern. Over time, different servers end up in different configurations, right? Resources run when not needed. Hard-coded IP addresses prevent flexibility, and difficult and inconvenient to test new updates on hardware that is in use, okay? This is very difficult. And that's the anti-pattern, right? Now, what we're interested in this, the best practice. We have to treat servers and other components as temporary resources. Why temporary? Because we dispose of them when we don't need them, okay? If there's an event triggering and a scaling in policy, right? We don't care. It's just eliminate that resource. Auto scaling would terminate an instance, and the other instances are exactly the same. So one less doesn't make any difference, right? So they're stateless. We can treat them as stateless, as not important, temporary, right? Now, you may have a question, Professor, when there's an auto scaling group, and then auto scaling is set to scale in, what EC2 instance will be terminated first? So probably you have that question. You have a bunch of 20 instances, right? And then all of a sudden there's a low demand in traffic, right? So auto scaling has a scaling policy to remove, for example, 2, if the CPU is between 60 and 80% usage, right? And then you set the auto scaling group to remove 2 instances. What do you think is going to be the instances that auto scaling removes? Because we have 20, right? 20. Well, let me tell you something. The first that auto scaling does is remove the one with the oldest configuration. Okay, the one that was created the last is the one that is removed the first. So I'm sorry, the one that was created first is the one that is removed first. Okay, so let's see what EC2 instances that auto scaling remove first. I think it might be probably in the auto scaling. Let me see here somewhere here. Okay. Okay. All right. So this is the way that autoscaling decides which one to terminate, right? So the default termination policy behavior is as follows. Determine which availability zone has the most instances, right? And at least one instance that is not protected from scaling, right? So the one that has the most is the one that has going to be, uh, the instance going to be removed from, right? And it has to be not protected from scaling, right? Now the second one, if this is not, let's say that all the ACs have the same amount of instances, then it says determine which instance to terminate so as to align to the remaining instances of the location strategy for the on-demand. This has to do with on-demand or spot instances that is terminating. Okay, this only applies to a termination to auto-scaling group that specify allocation strategies. Right. Number three, determine whether any of the instances use the oldest launch template or configuration. Right. So these are the steps that auto-scaling follows to terminate instances, right? Because when I teach you, I show you this is what happens when you stop an instance. This is what happens when the instance is not healthy anymore. So I'm going to create one, but if it scales in, how does he know which one to terminate first? So this is the steps that they follow. That's auto-scaling follows, right? Now, number four, for example, after applying all the above criteria, if there are multiple unprotected instances to terminate, determine which instances are closest to the next billing hour. Okay? Just in case this doesn't apply, okay, if it does apply, then it goes ahead and checks this, right? You're going to remove two, for example. What are the twos that, let's say that 6 instances were created the same day? So they have the same age in terms of configuration, right? So you have to determine which one is closest to the billing hour. Okay. I don't believe they're gonna. I mean, instances are created one by one. They're not created all at once, right? One by one, but in a group. So I guess that probably the oldest one is the first one, is the one that closest to the next billing hour. Okay. So as you can see, it's a little complex what autoscaling does behind the scene to determine which instance to terminate. Because so far we're seeing, yeah, okay, it terminated an instance, but what happens behind the scene? Okay, this is what happens. So I'm going to put here in the chat so you guys can read it later and understand a little bit more about this guy. Okay. So you may have a question about this in this hand, right? And also, if you want to go for probably a developer or a sysops certification, this is what you should consider when troubleshooting. Okay, because sysops is about troubleshooting. The whole exam is troubleshooting. I believe it is one of the most difficult exams you can ever take. Okay, for me, it was a pain to be able to pass it. Okay, because I don't have any experience as an operating administrator. I never worked on that. I worked on something else, but not that one. But I wanted to have that one because my job required it. Okay. All right, so we continue. Best practice, automate deployment of new resources with identical configuration. That's auto scaling. Okay, when you see identical configuration, you see these two words. That's auto scaling. Auto scaling or Cloudformation, right? Cloudformation creates different instances. You can create instances with the same configuration, and you can even create auto scaling with Cloudformation. Okay. So switch to new IP addresses automatically. You can auto assign IP addresses and test updates on new resources, and then replace all resources with updated ones. So you can use Cloudformation for that. Cloudformation will update anything, update anything and not remove the old ones. But if you update a resource, it will remove that resource and replace it with a new one. Okay. So what does infrastructure as a code mean? Automating your infrastructure, okay? Like I said before, whenever you hear infrastructure as a code, that's Cloudformation, okay? Define your infrastructure as a code, not as bundle of hardware components, okay? It is only code. You're creating an EC2 instance, right? So when you create an EC2 instance, you just put the code there, and usually people preferred, just give me 1 second here. So people preferred, just one moment. Okay, so what people prefer is use YAML, okay? Because YAML is less confusing than JSON. So I can have you say Cloudformation template, right? And then I'm gonna have extension YAML, okay? So whenever you see this question mark, exclamation point, this is YAML, okay? So what happens with YAML is that YAML works with keys and values, but what happened is that it works with indentation, okay? Indentation is super important in YAML, okay? So you have to be careful because there's a hierarchy system here, okay? So if you say my instance, right? Something like that, instance, and then we say here, I think it's type, right? Type AWS EC2 instance, okay? It's something like that, okay? So the first element, it's the section, which is this is mandatory in any single Cloudformation template, okay? And this is the name. The name is the second part. For example, now I want to write the properties of that particular EC2 instance. And then now, for example, I want to say the availability zone, right? And I want to use US East 1, right? It's not difficult. It's just, you know, the way it is. Image ID, okay? We have to come here and the console and grab the image ID from here. Okay, I'm gonna use this guy here. And then I put it here, right? So instance type, right? And then I can put here T2 micro, right? Okay. So what I can do now, I can create a security group here. Okay, it has to be the same level as the EC2 instance because it's a resource, right? So I can say, for example, SSH security group, right? That's the name, right? Because the first part is a resource and the second part is the name, right? And this is in the same level as the EC2 instance because I'm creating another resource. This is the resource section, right? The indentation here is super, super important because if you have an indentation problem here, you have a problem here. When you upload this in Cloudformation, it's going to tell you there's a formatting problem. Okay, so I'm going to put here the type. The type is going to be, you see this common patterns here, AC2, and then security group. Okay. Right? No. Security group. Okay. So now we have the properties again. Okay. And now we're gonna do create a group description. Group description. Right. What do we have here? Enable, for example, enable SSH access via port 22. Okay. So now I have the security group ingress. Okay. Why? Because I am working on the inbound rules, not the outbound rules. Okay. I don't care about the outbound rules because even security groups are stateful, right? So I only have to work in the inbound rules. Okay. No outbound rules. We don't need that. Okay. So ingress, CIDR. Okay. I'm going to have CIDR here. Okay. CIDR. If you know any, about this, you have to create a CIDR for your security group, right? Because you have to allow traffic to the security group. We are allowing traffic to every single from every single IP address, right? Why do I put this? If you know something, if you know about programming, you know that arrays is a group of elements, right? So we're creating a group of elements here that are part of this security group ingress property. Okay, so they have to be in the same order, the same space here. They have to be the same space here. Okay. So now we have from port. We are coming from port 22, and we are going to port 22, right? And the IP protocol is TCP, right? All of this we saw before, right? When you create these two instances, because Cloudformation, what it's doing is exactly this, right? It's using everything for you. Oh, I'm in the configuration, one moment. So if we launch an instance, we have to do exactly the same thing, okay? So we have to come here, you know, and the volume, we don't need a volume here. When we get to the security group, if you want to create one, you have to do this, right? The type is SSH, that's port 22, right here, okay? The protocol is TCP, is right here, IP protocol TCP, right? And the source is all the IP addresses right here, okay? So it's exactly the same. But now we want to create another security group. Now we want to create another security group, but now it's gonna be just web, opening port 80. So we say server, security group, server because you know it has you know port 80 access, right? Now I'm gonna do exactly the same. I'm gonna copy and paste. I don't want to type everything again, okay? But now instead of having port 22, we're gonna put port 80. And then here we're gonna change this, okay? You see, we created two security groups. Now, how do we connect these two security groups with this instance, right? I want to use two security groups. I could have used one, right? I could have put this here if I want to, right? but I want to create two for you to have an idea how to create more security groups. So what I have to do is come here and just put security groups, security groups. Why groups? Because it assumes that it may be more than one, okay? What I have to do here is just use a function in Cloudformation that it makes a reference to the security group. So now what we're gonna do is just put the name here, okay? And then do the same with the other one.
I have a question.
Go ahead.
Go to the bottom
Mm-hmm.
of this. Is there any protocol for the second security group, a TCP or
The same
TCP?
TCP.
It's the same?
Yeah, if we create here an HTTP thing, it's the same thing.
Okay, got it.
Okay. So now if I save this guy, right? I saved it already in my desktop. If I come here to Cloudformation, right?
What is it? Oh.
Cloudformation, and I decide to create a stack. See how right-hand side here? Create a stack, because that's what you create, stacks. Okay, with new resources, right? Then I can come here and say upload a template file, right? And I can choose this and come here and select Cloudformation. Cloudformation right here. You see a template here, okay? And then it's already here, right? It's already here. Now I can give it a name. My first Cloudformation template, right? So I don't need a key, anything. This is more advanced. I don't need any of this. So now I can estimate the cost. It's gonna take me to the simple monthly calculator. I don't need about that, I don't need that. So I can just come down here and create the stack. Okay. So it says creating process. Cider. You see, it tells you the error, and it rolls back. Okay. Let me see what happens here. Oh, I forgot this. You see how finicky it is? Now what I have to do is come back and create the stack again. And I'm gonna give it a different name because I have to delete the other one to be able to create another one with the same name. Okay, so now I'm gonna come here and say my first Cloudformation template. Okay. Here, I just create the stack here. Let's see what happens now. So it starts creating the EC2 instances, the resources. It is creating the two security groups, right? One is the web server security group, and the other one is SSH server. Okay. So creation for availability zone, US East 1. Oh my God, I know what happens. Remember that availability zone is, they need to have a letter. Okay. This is the region. If I do this, a region. So I have to have this. Okay. So let me delete this guy. So delete is complete. Okay. Now I can create, let me delete this one too. And now I'm gonna create another one. And I hope that this time it works. Okay. So I'm gonna put this again real quick. You gotta be patient for this. Okay. Then I can put my name again, my first space FN first. That's Cloudformation template. Okay. So let's see what's happening now. What happens now? The good thing is tells you what the problem is. Okay. Create complete. Now I created the two EC2 security groups. Right. Is the creation of the instance right now. If I go to the console and I check this here, there's one CloudFormation thing here pending. Okay. And it has this. It was created in the area zone that I um, selected, and then the security group is going to be the SSH security group. Right. This is one, and the other one is the web server security group. If I click on this, it's going to tell me that this is a security group that I created. One is for 80. The description is somewhere here. It's right here. Enable HTTP via port 80. Okay. And then the CloudFormation is telling me, give me all the resources that I need here. Now, this template is reusable. Okay. I can reuse it several times and I don't have to write it again. Okay. But you can see here, you can troubleshoot this here, right? And see all the resources, the status of the resource that you created, the instance, the logical ID. This is the name of that, the timestamp when it was created, right? And all the statuses, okay? The status reasons, okay? So you can see how effective CloudFormation is, right? Of course, you can create more complicated ones. You can create a scaling group, load balancers, DynamoDB tables, you know, RDSs. You can create anything here. Although there's a few services that CloudFormation doesn't support, right? Well, that's one. We can continue with the class. Okay, one moment. Okay, so the process for applying techniques, practices, and tools from software development to create reusable, maintainable, extensible, and testable infrastructure. Reusable, okay? Very important. This can be reused for anything you want, okay? There are other sections of the CloudFormation template that we're gonna speak about later, but this is the only one. I'm saying this in capital letter. We copy all uppercase, okay? The only the only section that is mandatory, okay, in a CloudFormation template, it is resources. It is the only CloudFormation section that is mandatory, okay? As you can see, I don't have any other section here. The only one that I have is resources, okay? The only one that I have here, okay? Later, I may create other sections, right? For example, parameters section to just to select the key for this instance, for example, or maybe I can write something like allowed values. Maybe you want to choose a different availability zone, not this one. This is hard coded, but I can give you several options so you can choose the one you want. Okay. So build and operate your infrastructure software. Software infrastructure, your source code, it can be in JSON. JSON is similar to YAML, okay? But it's more complex. Like for example, JSON would be, I don't know, something like this. Of course, here's not gonna be recognized because this template is in YAML, right? JSON, you need to put JSON, okay? But it's gonna be something like this, right? It's gonna be something like this. It's gonna say, for example, resources, for example, something like this. Okay. And then here you can about type. right? And then here I'm gonna have something like this. Okay, something like that. And then I need to put a comma. Okay, this makes this template more difficult. Okay, that's why people prefer YAML, because we don't need any comma, you don't need any curly braces or anything. You just need to know the indentation. Okay, to establish the hierarchy of this template. Okay, and even here a little deeper. You know, you go deeper and deeper, and you dig deeper and deeper and deeper. If you have something that depends on this, maybe is here, something that is even dependent. For example, this, and something that is even dependent is going to be here. So it's a hierarchy system, right? I prefer YAML personally. JSON is used for something else, for objects. This is an object, right? This is an object. That's why it's called JSON, JavaScript Object Notation. This is an object, right? That has keys and values, right? YAML also has keys and values, right? But it's different from JSON. Okay? I think it's simpler. Okay? And then so on, so on and so forth. So you start putting the properties, for example, properties. It gets even more complicated with the properties, okay? Because you have to go even deeper, right? So you have to go even deeper, and then in the properties you have to put, for example, image ID, and then put the image ID here. Of course, this is going to have different colors. If you choose JSON, right? If you create a new file, right? And then you save it and call it my first template .json, right? Then it's going to have a different icon here, and whatever I put here is going to look different completely, okay? Because it has a different format, okay? You see how it looks? Okay. So this is JSON, okay? And this is YAML. Two formats, the only two formats you can write a template in Cloudformation: YAML or JSON. So it's your choice. You decide. It's up to you which one you're going to choose. I personally choose this one. It's simpler for me. This one is more complex, and the standard has become that people using this more than that one. Okay. So whenever you hear that a company is looking for infrastructure as a code that is expressed either in JSON or YAML, what's that service? That is Cloudformation. Okay, very important. So the interpreter is the AWS Service API, you know, that the desired application state, desired infrastructure state. So this is what we're going for, okay? All of this, okay? But you don't need to know this in depth. This is more for developers, okay? But an architect has to know about this. Let's say that an architect is like a general doctor, right? A person that studied for 5 or 6 years is a general doctor, a comprehensive doctor. But then you go ahead and study a specialty, right? You want to be a developer. An architect is like that general doctor. It's someone that has to do a little bit of everything because you're architecting in the cloud. Now, if you want to become an expert in developing in the cloud, then you would go for the developer certification, for the DevOps certification, and then you're specialized in that. Okay, but an architect needs to know a little bit of everything. Okay, so it's good that you know this. Now, benefits of treating infrastructure as a code. So you have repeatability here. You can repeat it, and reusability, right? So we have here the development section here. So you have a load balancer, auto scaling group. You have a template here that you can create for this, right? And then you can repeat it for development, or you can reuse it for production, because maybe the production environment needs the same infrastructure, okay? The same infrastructure. You can repeat it and repeat it for this one, just in case you want to have um, some other sections in this department that need something similar. You can repeat the same code, right? But maybe there's another department, in this case production, but maybe testing, maybe I don't know, HR, or any other department that needs this to work. You can reuse it for this one, and you have the template here. Okay? You can even have nested CloudFormation templates. So one CloudFormation template connected to another one by using the export and import function. So you want to use, for example, you want to create EC2 instances with one template, but for that, let's say you want to create not EC2 instances, you want to create, for example, an auto scaling group, right? In one template, and you need the ID from the other template. What you can do is write an option. This is a section, no outputs. We saw resources, right? We're gonna see outputs later. In the output, you can get the ID from that EC2 instance and use it in another, export it and use it in another nested template by using the function import. Okay, that's possible too. So when do we do that? When departments are connected to each other, we can use nested templates. In that case, we're going to have a parent template and a child parent or child template. A child template can be deleted, but the parent template cannot be deleted because it depends. There's a dependency. There's a child that depends on that one. So first, you have to delete the child, and then you delete the parent. Okay. So this is look, this all concept can be applied to daily life too, because in daily life you have parents, you have children. The same thing in programming or in coding is the same thing. You have parent and children, like resources that are like the umbrella of the children, and the children depend on the parent. So similar to that. So we have another maintainability here, consistency and parallelization. Okay. So we have, in this scenario, we have a template that was updated to our new security groups, right? So in the other one, we didn't have any security groups, right? We only had the auto scaling group, but in this one, we added a security group, right? And we updated the template. Okay. Guess what CloudFormation does? It just modifies this. It doesn't delete the instances and restore the instances again. No. What it does is just modifies this and adds the security group. That's it. Nothing else. Okay. So I can simply come here and modify this and change the name of the security group, right? And it will create another one, or simply add another something else here, and it will add this, whatever I added. Okay. Remember, it has the same name. If I change the name, it creates a new one. But if I put the same name and I change something here, what it does, for example, if I change here the instance type, right? What it does is updates the infrastructure. Okay. So that's what we did here. We added security groups. Okay. So the template was updated. And then what it does, it updates this. So you can maintain this easily. Okay. And make it consistent with every single department. Okay. And at the same time, you are working parallelly, in parallel, creating resources in parallel in different departments at the same time. Okay. It's recommended to have a different template for every department. Okay. That's the best practice, right? Don't have two templates for the same department. It's better to use one template for department. That is mostly one of the questions in the DevOps exam. That's what I saw in my exam. Okay. But you need to know about that. Okay. One template per department. Okay. That's super. That's better. It's even more loosely coupled. Okay. So do you have any questions before we continue? No questions? Do you understand CloudFormation so far?
Yeah, so far so good.
Any confused student? Is it getting tough by the minute? No? Yes? Maybe? Perhaps? No?
It's just a lot to digest, but it's not getting tough.
It's not?
No, not to me. It's not getting tough. It's just
Yeah. Remember the student I spoke to you about the beginning that got a job and then he began to make 80,000 a year, a student that was studying with us. So that student, his job is is becoming an expert in CloudFormation. That's his job. His job is only working with CloudFormation. It's a cloud engineer job. CloudFormation only. That's it. No more than that. So the guy has been able to become an expert in CloudFormation because there are architectures that are only created with CloudFormation. You can create an entire architecture using these templates. That's it. Okay. So there are jobs that only in the job description, it tells you that you have to know CloudFormation and you're going to be working with CloudFormation all the time. Okay. So this allows you to launch, configure, and connect AWS resources with JavaScript object notation, JSON, or YAML formatted templates, okay? Like we saw before. So we have the template here. We have the template, and it's JSON or YAML formatted files describing the resources to be created. You treat it as a source code. Put it in your repository. So that's for this is more for a development aspects, but you know you need to know that you put this in your code and repository, okay? In code commit right here. And by the way, let me, before I do anything else, let me delete this tag. I don't want to have this running because I tend to forget later, and then I'm gonna forget. Okay. So I'll come here to code commit. Okay. And then you can put your CloudFormation template here. Create a repository, right? And then put the CloudFormation there. Okay. There's more to this, right? There's much more to this. There's another guide that we can use, but that's for serviceless. Okay. This is mostly for servers, right? But there's another one for serviceless, which is SAM. Okay, SAM. I'm gonna put it here, SAM. Okay, SAM templates. SAM templates is serviceless application model. Okay, it's a template similar to this, right? It's similar to this, and even you have to put something here, like a transform section that is telling CloudFormation that this is a SAM template, and then CloudFormation will use that template. It's mostly used for serviceless applications, for creating API gateways, for creating Lambdas. Lambdas are mostly created with SAM templates, even though you can create a Lambda function with CloudFormation. But if you want to go serviceless, SAM templates is the guy, okay, for that, okay? You don't need to know much about it, but just for you to have an idea that there's another guy that we can use for templates at the SAM, okay? The SAM is nothing else than CloudFormation, but for serviceless, okay? So we have a CloudFormation engine, a AWS service component, interpret AWS CloudFormation template into stacks or AWS resources. Here we have it. So this is what it does. It interprets everything in stacks, right? Stack. That's what you create when you create an infrastructure, a stack, right? Create a stack. Okay, create stack. And the stack is a collection of resources created by AWS Cloudformation. We just did that. Tracked and reviewable in the AWS Managed Console. You can track it here. Once you create it, we don't have anything now, right? But for example, this one, you can track it here. You can see the events, right? You can see the resources. There's no resources here. Okay. You can see the outputs. There's no outputs here. Usually what you see here is the IDs that we need. You can see the parameters, just in case we have a parameter in the template. We don't have any. We might see some later. We have the template here. In this case, we don't have anything, but the template exactly the same that you see here. You're gonna see here in this section, exactly the same. And the change sets, things that you can create, when you change something, okay? It will tell you here, when you create something in the template, you're gonna come here to this change section, and it's gonna tell you what resource they're gonna do, right? You're gonna add. There's no modify here. There's no modify because we are not updating any template. When you update a template, what it says here is modify, modify, modify. And if it's replacing one, moving one to put the other one, it's gonna show here like yes, no, or true, false, true, false, true, false. Okay. So you can track everything in a CloudFormation template. Okay. You can track everything here. Okay. And you have some actions here that you can perform. Okay. Okay. Whenever you see this word drift, okay, drift. What is a drift? Sometimes when you create a stack and you create an architecture with a template, people go to the console and make the changes in the console. Okay. Don't do that. If you create a stack, make the changes in the template and then upload the template again. If I create these resources and I change, for example, the site, no, the site I cannot change it in the security group. Wait, I can change this. If I change the cider, there's gonna be a conflict between what I'm changing in the console and what I created in the stack. That's called a drift. Okay, it's right here, drift. Okay, you're gonna see a drift here. There's no drift here, but if you make a change in the console and not in the template, you're gonna get a drift. That's an error, right? There's a mismatch there that you have to fix. Okay. So you can have some cross-stack references. Like I said before, you can use nested stacks and reference one to the other. Okay. So ways to work with AWS CloudFormation templates: simple JSON or YAML text editor, CloudFormation Designer. So you can have the designer here. I think the designer somewhere here. Where we have the templates. Let me see here. Template. There's no template, right? But when the template's here, this is going to be enabled. So you can see in your CloudFormation. Let me create that. Let me just create the same that I did. Let me create it real quick, and then we continue with the slides. So I can show you that later. Okay. So I'm going to name it the same. I'm going to put CloudFormation template. CloudFormation template. Okay. And I'm going to just hit next and then next and then create steps. Okay. So we're gonna revisit this later. In the meantime, let's continue. So it's available via the AWS console, management console. It lets you drag and drop resources onto a design area to automatically generate a JSON formatted or YAML formatted CloudFormation. So with the designer, you can drag and drop and make an infrastructure, and it's going to give you the template for you. Okay. So you edit the properties of the JSON or YAML template on the same page. Open and edit existing CloudFormation templates using the CloudFormation Designer tool. Okay. So I can see the template here. You see? Now I can see the template. Okay. Exactly the same as here. Okay. Now I can come to the designer here, the designer, and I can see in the designer my infrastructure. You see? You see, that's what I created. I created an instance, right? I created 2 security groups. There's the names, okay? The type right here. You see, it's beautiful. Now, maybe I want to have an API gateway. Something I put it here, right? And then maybe I can put it depend on, depends on maybe this, right? And then I could put an API gateway that depends on this, right? And maybe it depends on something else, no? Okay, so maybe it depends on this guy. Okay, so that's gonna give you a template right here. You see, it gives you a template. It's a little more complex, okay? But you can see the API gateway here that has a depends on my instance, right? See how beautiful this is? So this guy depends on this. And it's very clear stated here in the template. You see, depends on. All right, that's a property. It means that this guy will be created after the instance is created. Okay, because it depends on it. Okay, so the design is very useful to create infrastructure or to take a peek at your infrastructure, the one that you just created, right? Okay. So just for you.
How did you get to the designer again?
All right, so when you come here, I'm gonna close this. Okay. I go to my template, right?
Mm-hmm.
And then when I get here to the template section,
Mm-hmm.
I go here to this in designer.
So you have to have a template in order for you to get to the
Yes.
designer.
Well, no. If you want to see this, yes. If you want to create your own, you can just drag and drop here and put it here. And then it will give you the template. But it's gonna be more complicated, right? Okay, this is the one that I have right now, right? But you can come here and create another infrastructure or just improve this one. You see, I just added the Amplify app, right? It's right here. Okay, and it will give you this either in JSON or in YAML. Okay, I'm choosing YAML here. I can say JSON. You see how more complicated. Okay, more complicated. Okay, so I can delete this guy, and this is a template that I created before, the one that we just created. Okay, and this is gonna be YAML. Okay, of course it has some other stuff that we don't need, like this designer, metadata, but basically it contains what we created before. Okay, it's right here. Okay, this guy, and it's in alphabetical order, it seems. This guy. Okay. Just in case you want to see how your infrastructure looks after you create it. Okay, like you have maybe you want to show your boss or your supervisor, you want to show him a visual of your infrastructure created in Cloudformation. This is the guy, the designer. Okay. All right, it's right here. Okay. All right, so I don't have time for this. So we continue. How should resources be grouped together in templates? So organizing your AWS CloudFormation templates, assign resources to CloudFormation templates based on ownership and application lifecycle. At a minimum, separate network resources, you see, network resources, security resources, and application resources into their own template. That's what I said before. You know, all the ones that have to do with DVC, subnetting, route tables, all those guys, one template. All the guys that have to do with IAM, CloudTrail, Trusted Advisor, I don't know, all those guys, you know, just put them here, okay? And application resources, for example, EC2s, security groups, keys, all those guys, you put them in one template, right? For example, a network resource template named Network Share Tier VPC GW NAT template may include definitions for the following resources: VPCs, subnets, internet gateways, route tables, and network ACLs. Okay, so you're gonna be more organized, you're gonna be more loosely coupled, you're gonna be more structured, you know, if you do that, right? Avoid sharing a single template across applications for resources of the same type unless you are deliberately centralizing control of that resource. Okay, so you don't want to have too many things in one template, okay, across numerous applications. If you want an application, if you have an application template that supports only one application, changes to the template only affect that one application. Loosely coupled, don't forget that, loosely coupled. If you have an application template that supports several applications, changes to that template will affect several applications, okay? So do not use one template to define the security groups of 10 applications, okay? Don't do that. Store templates containing security resources in a separate repository from all the templates, okay? Security is security. You know, that's a very delicate topic, and that's a very important thing that you have to secure, and you do that in a separate template and in a separate repository, okay, in code commit, okay. So example, AWS Cloudformation groups, front-end services, consumer, website, server website, mobile backend, search, payments, reviews, recommendations, shared services, customer relationships, management, databases, common monitoring, alarms, subnets, base network, VPCs, internet gateways, VPNs, NATs, identity, IAM policies, user groups, and roles. So this is a good way to structure your infrastructure in separate templates, right? To be more consistent in your infrastructure. Okay, so you can work like this, you know, and the different resources that are associated with this guys, then you put them in this particular templates. Okay, and then what you can do is just use the import and export functions to link one to the other. Okay, just in case you need, for example, one role from here, the ID, not the ID. Roles don't have an ID. Roles, they have an ARN, an Amazon resource name. You want the Amazon resource name from here to, for example, I don't know, work from here, right? So you can, what you can do is just export it from here, from the output section of the template, and import it here, okay? But you're not mixing all up together, okay? They're in their own templates, separated from the others, okay? Which is pretty good. So anatomy of an AWS CloudFormation template. So we have the description here, the JSON string, right? You have the metadata, template metadata. What is the metadata? The metadata is the data about the data, okay? Data about the data. Let's say that you want to know the specific metadata of a specific EC2, for example. You can bring that information. You want to know the ID or the instance type of that data of that EC2, so you can bring that. Okay. The description, what it does is a text string. Okay, it's just a string. What is a string? A string is just a string. It's just a group of characters together. It's just a word, a sentence. That's a string, and they usually inside quotation marks, okay? So if you put quotation marks in YAML, it doesn't matter, okay? It doesn't matter if you put it or not. But in the case of JSON, yes, you cannot do this in JSON. Look at the color. When it says red, it says, whoa, this is on fire, something's happening, something is wrong, right? So I have to put the quotation marks so it all goes back to normal, right? Or if I do here, something happened, right? I have to put here because that's the syntax of that notation, okay? So that's a string, okay? Whatever is inside quotation marks is a string, okay? It's a literal string between 0 and 1024 bytes long, right? As a string. Cannot use a parameter or functions to specify it, okay? So it's usually inside quotation marks. For example, this template builds a VPC with one public and one private subnet, okay? Just in case you create a template to create VPCs, give it the description. So when people use that particular template, they know what this is template is for, okay? So the description part. We have the metadata, okay? It's a JSON object that provides additional details about the template, including settings or configuration information that some AWS Cloudformation features need to retrieve. Can be specified at template or resource level. Instances, for example, I want to just get the information about the instance, right? Metadata instance. And I want to get information about databases, right? So I use the metadata section for that. Okay. Now we have the resources one. We just saw the resources. That's the one that we just is mandatory, right? Don't forget that. Resources and the properties that will be included in the stack. Each resource must be declared separately, except multiple instances of the same resource. Resources declaration has the resources attributes. These are the attributes down here, okay? So it has properties and it has attributes, okay? So resources attribute depends on, don't forget that, depends on is something that depends on that, right? Very good, Tomaro, thank you. So we have here resources, application server instance, just the name. You can give any name you want. And by the way, this is on JSON, okay? This is in JSON. Whenever you see these guys in quotation marks and these curly braces and all that, you see key and values, you know, this is something that is in JSON, okay? So we have this guy here. This guy here is an attribute, okay? It's not a property. The properties are inside the property. You see this here? They're inside the property. But the depends on is in the same level as the property. You see, there's nothing, I mean, it's not inside, it's just in the same level. It means that this is an attribute. These are properties, and this is an attribute, okay? So this resource depends on my DB. DB is here, okay? We're creating here an RDS, I'm sorry, one moment. We're creating here an RDS, right? I think it jumped to, okay, we jumped, sorry. Resources here, type, we saw this already, user data. Remember the user data? The user data when we create an Apache server, user data. If you watch my video on how to create EC2 instances with a load balancer, you see that on user data, I just install an Apache server. The user data is used for that, okay? And we have to use this function base 64, okay? What it does is it tells CloudFormation to interpret whatever code that comes after this to interpret it, okay? And then user data can be used. This is more advanced. If you study for the developer one, you're gonna know how to do this, okay? Not for this exam. Availability zone, my queue, you're creating a queue here. A queue is SQS, right? SQS, that's another server. Is, by the way, is serverless. It's using the serverless architecture, SQS, okay? It's for decoupling your infrastructure, right? Very important. Now here, we are in the depends on attribute, right? So what it does is it's telling CloudFormation, do not create the resource app server instance until you have created my DB resource. Okay, that's what you tell it. So basically, it's very plain English, right? Okay, it's plain English. So when it depends on attributes required, when the following resources depends on a VPC gateway attachment when they have an associated public IP and are in a VPC. All the scaling groups, they depend on that, on a VPC gateway. Amazon EC2 instances, elastic load balancing, load balancers, elastic IP addresses, elastic RDS database instances. Amazon VPC routes that include the internet gateway. So these guys, they need a depend on attributes because they're all the resources that need to be created before. Okay. So a wait condition, special CloudFormation resources that pause the creation of a stack and wait for a signal before it continues, right? So use the wait condition to coordinate the creation of stack resources with other configuration actions external to the stack creation. For example, you're creating several resources and you have to wait for a signal like this resource has been created. Let's go ahead and continue creating the other ones, okay? This is something that you will see in more details if you study for your developer certification, okay? So for this one, what you need to know is that wait condition, it begins after the successful creation of the EC2 instance resources has happened, okay? So this is very important, okay? The wait condition, wait for this, and then continue the rest of the properties here. All right, wait condition. Use the creation policies in the templates. Okay, pause the creation of the stack and wait for a specific number of success signals before it continues. So auto scaling group, we're creating auto scaling group here, resource here, type AWS auto scaling auto scaling group. Properties, availability zone. We're using the function get AZs, right? Get AZs. This is a global variable, right? Launch configurations name. We're referring to launch config. This is something that we created aside. We have to create a launch configuration. Don't forget. Design capacity 3, minimum size 1, maximum size 4. Okay, and then we're creating a policy. It's a resource creation policy. The name is resource signal. And then the count is going to be 3. And it's going to wait 15 minutes. It's going to wait 15 minutes and then it times out. Okay. So everything has to be created before those 15 minutes has passed. Okay. So this is a high level explanation of the depends on and the signal thing, the resource signal part. But basically what you have to know is the wait condition. It will send you a signal. When one resource has been fully created, then you can continue with the stack. Okay, that's the basic of that. What is going to break? If you share your template, what could potentially break here? Things that are specific to your environment, such as Amazon EC2 key pairs. You know, maybe the keys don't exist anymore. Maybe the keys were deleted. Okay, maybe the keys are broken. Maybe the key is missing the private key or the public key. This is a key pair. Okay, something is wrong. Security group names. Okay, Maybe they changed the security name in the console. Okay. The subnet ID maybe is wrong, right? And the EV snapshot IDs, right? If you want to restore volume from the snapshot ID, it may be wrong. Something maybe do that, okay? Maybe someone changed that. So there's one thing that you can do if you think that your template may change in the future. You can use something called parameters, okay? Parameters. What if someone deleted the keys, okay? But when you have parameters, you don't have to specify the key. What you can do is just add the parameter section, and then the person, what you have to do is just select that, okay? Let me see if I can find something here for you guys. One moment. Okay, one moment.
If you go,
Huh?
I was going to say, if you go a couple of slides forward, there is an example.
Yeah, but I'm trying to find something here.
Oh, okay.
Okay, so for example, I can add here. I can add here maybe maybe I can say here parameters, right? And I can say instance, give it a name, instance type parameters. Right? And then here I can say type string. And then here's, I can say default. The default is T2 micro. That's the default one. But I can do this. Allow values. And I can say T2 micro. I can say T2 M1 small. And I can say M1 large. Okay. And I can say here description, enter T2 micro 1 M small or M1 large. I can say that, and default is T2 micro. Okay. It's just to give the person the choice to choose whatever they want. And then here I can put reference and then the name of this guy here. Okay. Okay, so now I can go ahead and go to Cloudformation and upload this guy. Okay. And then what I'm going to do is update here, right? I'm not going to go through the whole process again. I just replace the current template. And then I'm gonna come here and choose this. Let's see if it works. It should work. And then you see. So just in case I want to give someone the opportunity to choose whatever they want, and I can do the same with the key, okay? And let's say that someone deleted a key that I'm used to right? To using, but maybe I have another one, so I can put allow values here and choose whatever I want. So I can do this M large, right? And then I can come here and do next, right? And update the stack, right? So the change sets, I should have seen that before. So we're updating the stack, right? Now the template is different. You see, the template is different now. I have some parameters. Okay, and the resources are being here. It's updating. The only thing that we have to do is update the instance. That's it. Nothing else, right? We don't have to do anything else. It's just update the instance because we're changing the type, and we just scaled up, right? We increased the power of our EC2. We had T2 micro, and right now we're going to have large. Okay. So this is how you update an EC2 instance. And guys, I'm going to give you a break. You have 10 minutes break. It's 2:32. I'll see you back here at 3:42. Well, guys, we're back. Ready? So we were saying that we can create parameters, and then here we have a parameter set of parameters. So values you can pass into your template at runtime, allows stacks to be customized at launch of a template, and can specify allowed and default values for each parameter. So when is this important? When you think that your infrastructure may change in the future, right? You can have parameters, okay? So you don't have to be specific about some values. You can have several options, and you can even ask your account, what do you have available? Okay, give me that, right? So in the case of the keys, the same thing. Okay. So we have here instance type parameter. So we have the same thing here. It's exactly what I did. So the description entered to micro, the default is like micro. And then we have this, but this is in JSON, okay? I did it in YAML, okay? This is YAML. If you compare both, I believe that you're gonna agree with me that this is more complex. This adds complexity, and it's a little more confusing to understand. Okay? So mappings, when do you use mappings? Okay. When you want to use specifically one key, you have the key and then you have the value here. Specifically, you want to use an AMI that is in a specific region, right? So you want to reference to that, and there's a function that is called find map. Finding map is the one that you give it the key, and it will find that particular value for you. Okay, just in case you want to have a specific value. So that's when you use a mapping. Okay, so region is a type to AMI ID. So you have the first value here, the first key here, is US East 1, and then you have two values here. We have the MI that small, and then we have AMI this number, TDO that small, AMI this number, and then you have it's a set of keys here that they have a specific value, okay? So that's what mappings is for, right? Okay. So conditions. Control whether certain resources are created or certain properties are assigned a value during stack creation or update. For example, you can have a template, and then you can have a condition if the instance is from the development department, create this EC2 instance. Okay, if the department is the development department, create this instance. If it is not, don't create it. So condition, that's what it is. You can have some certain parameters that if the conditions are met, then the action will take place, right? That's what conditions do, okay? So conditions, for example, parameters here, we have M type, and then the M type definition, for example, specify if this is a development, QA, or production environment, type string, default def, allowed def, QA, and prod. Conditions, create prod these resources. Function equals. If it is equals and the end type is prod, then create that. Okay, then create that EC2 instance of whatever resource you're creating. Okay, so now this, guys, this is the same as this. Okay, this is the short version of this. I could have said here, this. Okay, but I prefer to use this. Okay, so whenever you see this guy, this is the long way to do it. All right, so this could be like this. Same thing. Okay. Okay, so create prod resources condition evaluates the true to true if n type is prod. So if it is prod, if you select prod, when you have this drop down menu here, then you're gonna create resources. Okay. And then when you create the EC2 instance, you're gonna have a section that says condition, and then you put create prod resources, and then the EC2 instance will be created if it is prod. All right, but first you have to establish the parameter and then the condition first, and then you call that, you reference that later to create the EC2 instance. So building environments with conditions, right? So we have here kind of scary graphic. Okay, so we have a prod and a dev environments here, right? So this prod has 2 availability zones, 1 and 2. This one has only 1. Okay. So it's the same template, but the problem is that if it is dev, you only create this, right? If it is prod, you're gonna create more, right? You're gonna have more resources, right? You're gonna have 2 availability zones. You're gonna be more highly available. You're gonna be fault tolerant because you have multi-AC here. You have a master and a standby database, and then you have this, you double the capacity, right? You only have 2 here, now we have 4. You only have 3 here, now we have 6, right? 6, so you double the capacity. Why? Because for dev, we don't need to be highly available. Dev is just for developing, right? But once you are in production, you need to be highly available and highly scalable and all those things that you need to be when you are out there. All right. So the condition is the one that facilitates this. Okay. Again, if it is dev, only create 1 availability zone. That's all we need. And then if it is prod, then create 2. All right. Okay. Good. So that's what conditions are all about. Outputs. Okay. Outputs is the one that lets you retrieve a specific ID from a template to use in another template. Okay. Or just to use in a specific template. For example, let's say that you create, you host a website and host a static website in an S3 bucket. In the output, you can print that link, the URL, and then you can click on it, and then just, you can find that in the S3 bucket, but you can also find it in the output section of the Cloudformation template right here, right? You can find it here too. There's nothing here because I never used the output, right? Okay. Good. So what about resources and features that are not directly supported by AWS CloudFormation? So use AWS CloudFormation's custom resources. Custom, that's what you have to create, a custom resource feature to plug into your own logic as part of the stack creation. Example, provision a third-party application subscription and pass the authentication key back to the Amazon EC2 instance that needs it. Okay? Or use the AWS Lambda function to peer a new VPC with another VPC. Okay, so you can create a Lambda function and then just establish a VPC peering connection with that. There's no way, there's no VPC peering resource or anything. Okay, that's something that you have to customize. So you have to customize and create a custom resource. Okay, that's what a custom resource is. Something that CloudFormation doesn't support. All right. So for example, here we have a CloudFormation template. Response with output. Okay, success or fail. All right. So we have a CFM verifier here. Properties, service token, function join. You have to join this with this. Okay, there's another function that you don't need to know about, but just see it. I'll be able to identify it probably. So we have the Lambda functions on hard coding here. Maybe Lambda function refer to the region and then account ID, a CFM verify Lambda. So basically the IRN is composed by this. Okay? Composed by starts with Lambda and then the region and then the account ID and then the CFM verify Lambda. All right. So actually what we're doing here is just grabbing the ARN of that particular Lambda function, okay? And then creating a resource. And then what happens here is AWS Formation passes custom data and the response with AWS 3, you're a success or fail. It sounds a little bit complicated, but this is just the way that AWS works when it comes with custom resources in CloudFormation. Believe me, you don't need to know much about this just to be able to know that a cloud custom resource is a resource that is not supported by CloudFormation, and then you need to go ahead and do some workarounds to be able to accomplish what you're trying to do. Okay? So other infrastructure as a code services, we also have Elastic Beanstalk. We know about that. The difference between Elastic Beanstalk and CloudFormation is that CloudFormation is infrastructure as a code. AWS Elastic Beanstalk is platform as a service, and also Elastic Beanstalk it's not written or anything like CloudFormation that you have to create a template. Elastic Beanstalk, what you have to do is just write the code, either Java or .NET or Node.js, whatever platform that CloudFormation supports, and then you upload the code. You zip it first, and then upload it. That's Elastic Beanstalk work. Did I say CloudFormation? No, it's all the platforms that the Beanstalk support. AWS Ops Works. This is for automation. Okay, it uses instances like Puppets and Chef. Whenever you hit Puppet and Chef, that's Ops Works. This is more for the developer certification, but this is the guide that you can use to create stacks too. You create stacks, and you can create EC2 instances as well. So you can come here and, sorry, it's not EC2, it's OpsWorks. Okay. Oh, I have instances running here. That's why I was charged. I've been charged. I now realize that. Weird. I don't have any instances here. Do I have any instance? I don't have any instance. Time-based, load-based, no. Okay, I don't have any resources, so I don't know why. Okay, so with these guys, you can create a stack, okay? You can delete the stack just in case I don't have any instances or anything. But with this guy, you can do a bunch of things, So you have Chef here, okay? You can have Puppet here. Those are instances that you can create, right? But this is mostly for automation, okay? So Observe for Chess Automate helps you automate, provision, and configure your environment, and Chef Automate platform delivers DevOps. So this is for the DevOps exam, nothing to do with the developer. And the developer, it doesn't show in the architecting, but for you to have an idea that you can also automate your code with OpsWorks, okay? Also, you can use Amazon Easy to Run command. And if you go here to Systems Manager, okay? Systems Manager is the one that you can use to patch several instances at the same time. You have something here, run command right here. So you can have a run command here. And here you can look for just owner. And you can say owned by me, because you can create your own run commands. Owned by Amazon, owned by me only, me or Amazon. So I can say here Amazon, and I can have all these commands that can be run. For example, this one, the content, for example, here, you have a lot of scripting here, scripting, version details, source type, specify the type, all this. But this document is used to run Ansible playbooks. I don't know if you have heard about Ansible. Many companies use Ansible on Systems Manager managed instances. Okay, so basically, there's another way to automate your instances or your infrastructure by using Manager, AWS Instance Manager, and then run command. Okay, that's another way. Of course, you have to install the System Manager agent in the EC2 instances. Even though, by the way, with this new platform that AWS has been improving, I think that the instances already have that agent installed. So you don't have to install anything. You just have to, when you are here, you have to look for a section that says managed instances, okay? And then I lose the connection here probably because because I delete this guy. I deleted this guy before. This is an instance that supposedly was in an on-premise office, because whenever the instance starts with mi, that means that the instance is in on-premise, right? Usually instances that are on AWS starts with I. Like for example, this one, you see I. When it's on-premise, it starts with mi. Or you can have a third-party application on AWS EC2, like for example, Jenkins or things like that to automate. So AWS Elastic Beanstalk is an automated deployment and scaling service for web applications. AWS Elastic Beanstalk accepts Java, .NET, PHP, Node.js, Python, Ruby, Go, or Docker code. It deploys on Apache and Nginx, Passenger, and IIS servers. All of this you can do with Elastic Beanstalk. A deployment with AWS Elastic Beanstalk can automatically handle load balancing, health monitoring, automatic scaling, application platform management, code management. Okay, so if you come to Elastic Beanstalk, okay.
So Elastic Beanstalk, it's more than just deploying resources. it also does the monitoring. Is that correct?
Yes, because you can have CloudWatch and everything there. Uh, you can deploy too with CloudFormation. Okay? You can deploy with S3 as well. Okay.
So why use one versus the other?
Well,
So
CloudFormation is reusable. Okay, it's reusable. You have the template there, and with that, you can have more control on the resources. With
Elastic Beanstalk, you can't reuse the.
you can reuse the code. Okay, CloudFormation creates the resources that you want. Elastic Beanstalk creates the resources for you. You don't have to. If I upload something, on Elastic Beanstalk, I'm not telling Elastic Beanstalk create a server, create a security group. No, it will do it for you. Okay, it will create the service for you. With CloudFormation, you have more control. You can give it a name.
To be more have more granularity of how, who, what, where, and with conditions.
That's right.
Versus Elastic Beanstalk. Okay.
Yeah, you're gonna see Elastic Beanstalk how it works now. Okay. So we're gonna choose a platform. We're gonna use Node.js. This is just a sample application, right? The code is already written. It's just a sample. Okay, so create the application here. Okay, it's gonna create an environment for you. You can see here how it begins to create. And the first thing it does is it created an S3 bucket. See here? But look at the name. You have no control over that. The name has been chosen for you. Okay, which is a pretty long name, right? With CloudFormation, you can create an S3 bucket and then you give it a name you want, right? If I go to S3 now, I can see the CloudFormation, the Elastic Beanstalk S3 here. You see? Now, I continue here. It created a security group name.
Is that because perhaps it's an automated process and it comes back and I saw the video that you posted. So it looks like it does a monitoring for you automatically. So it has to look for some sort of.
We're gonna see the configuration later when everything is created. Okay, so I created an IP address. I never asked for an Elastic IP, right? When I created the CloudFormation template, I never created an IP an Elastic IP here. Okay, CloudFormation creates one for you automatically. It created a security group for you. Elastic Beanstalk knows what is needed to keep or to make that code run. Elastic Beanstalk knows that. Okay, we just upload the code. It's a platform. Upload the code and it begins to create everything that is needed. With CloudFormation, we have more control. We just tell CloudFormation, this is the resource that I want. That's it. This is the resource that I want. Okay, we're not uploading any code like you do with Elastic Beanstalk. Right? Even though you can have code in CloudFormation, but that's even more complicated. But they're two different services, and they're both for deployment. Okay, but CloudFormation is now used for blue-green deployment. Elastic Beanstalk is, but that we're gonna see probably later. Okay, now the environment has been created for you already, right? You can have here all the things that happen, right? Now, if we come here to the configuration, okay, so you can see the instances. This is the security group that was created, okay? It has the monitoring. The interval is 5 minutes, so it didn't create an enhanced monitoring, a detailed monitoring for me. It's just to have the regular one, the one that is every 5 minutes, okay? That's the basic monitoring. It has here a load balancer. There's no load balancer here. Okay. Rolling security. It doesn't have a key pair. It has an instance profile. Service rope. It has one here. Okay. is the one that allows Elastic Beanstalk to create the resources. We have some CloudWatch custom metrics environment, some here. We don't have HTTP here. It's in Node 400s, in Node for 400 disabled. Network, this environment is not part of a VPC. Okay. So we can edit this, right? And we can change things, our scaling group, for example, load balanced. Okay. And then we can make here on-demand instances, create another, maybe increase the size, the capacity, minimum size, maybe change the type to another one. We have the AMI here, maybe change the AMI. Okay, you know, change it. How many availability zone? Maybe 1, 2, 3. Scale, cool down, network capacity. You know, the changes happen after everything is created. But with CloudFormation, you can do that before it's even created. Okay. So we have a bunch of things that we can fix here. Now, Elastic Beanstalk, what happens, it gives us this is a URL that you can click, and then boom. You see, your first AWS Elastic Beanstalk Node.js application is now running on your own dedicated environment in the AWS cloud. The environment is launched with Elastic Beanstalk Node.js platform. Okay, so this is Elastic Beanstalk being deployed. This code was already written, right? It was written for you. It's written in Node.js, okay, which is an runt environment for JavaScript, okay? In CloudFormation, we don't have to use any code, any programming language. We just have to use JSON or YAML. That's it. Okay. Two different things. They're both used for deployment, but if you want to use it for a blue-green deployment, like we're gonna see right now, Elastic Beanstalk is the guy. Okay. So a deployment with AWS Elastic Beanstalk can automatically handle load balancing, health monitoring, automatic scaling, application platform management, and code deployment. Okay, code deployment. So the blue-green deployment on AWS Elastic Beanstalk production is fully scaled. Pre-production is minimally scaled. Both Elastic load balancing load balancers are kept warm. Kept warm it means that they're ready. They're ready to work. Because something that you have to do is when you're gonna have a peak of traffic in your infrastructure, you have to call AWS to warm up your Elastic load balancers for them to be warm up and ready to work. With Elastic Beanstalk, they're always warm. They're ready to work. If anything goes down, you can roll back quickly. Okay, roll back at the previous version to what it was before. Now, the green guy is the new guy. Okay, and the blue is the previous one. Okay. What happens? We can use Amazon as Route 53 for failover. So we can come from this guy to this guy, and then there's something called Cannery Deployment, not Cannery Deployment, that is set. Like for example, you want to move the traffic from the blue section to the green section, only 10%, right? 10% only. And after 10 minutes, for example, you could go 5, 10, 15 minutes. After 10 minutes, move the remaining 90% to the green section. So that's blue-green deployment. You have to understand that. We are not sure that your infrastructure is going to be fully operational in the green environment until we test it. When we test it, then we can go ahead and move all the remaining infrastructure to the new environment. Okay, so that is what blue-green deployment means. Okay, let's say that we just keep it running, the green environment, keep it running for 10 minutes. Everything is fine in 10 minutes. So it means that the guy, you just set the time, right? You can have 10 minutes or more. Set the time, 10 minutes, everything is fine. Then this new environment is ready. It's ready to receive the entire traffic. Okay, so that's what blue-green deployment is. Okay, so you have to understand that. Yes.
Professor,
Yes.
I'm gonna have to head out. So
Okay.
I'll watch
just
the video after you upload it. So
good.
okay.
Thank you. So blue-green deployment on AWS Cloudformation, you can do it here too. You know, but it's a little more complicated with Cloudformation. The customer story, an internal security team has not approved the usage of Elastic Beanstalk. Therefore, the customer had to use Cloudformation to implement blue-green deployment. But the preferred way is Beanstalk. That's the first resource that people use or look for when they need to deploy blue-green. And then if you don't have any choice, then you have to use Cloudformation. Okay, so it's gonna be a little more complicated. Okay, you know, it says here that it takes more effort. Okay, so the preferred way is Elastic Beanstalk. Okay, you have to manage less that Cloudformation. Okay, you remember you only have to write the code, but in Cloudformation you have to create the infrastructure. Okay, only once, because then you can repeat that code again. But with Elastic Beanstalk, you don't have to create the infrastructure. Elastic Beanstalk creates it for you based on the code that you upload. Okay. So stack 1, stack 2. Okay. So you're moving from stack 1 to stack 2 using Route 53. Okay. Okay, AppsWorks is a configuration management service that helps you configure and operate applications of all shapes, sizes, using Puppet or Chef. Okay, don't forget Puppet or Chef. That's AppsWorks. Define the application's whole architecture and specifications included package installations, software configuration, resource compute storage. Yeah. Don't sweat on this. This is not, you don't have to know much about AppsWorks because that's for another certification, but at least you need to understand what it does. Okay. So start from the templates for common technologies, application servers, databases, or build your own. So you can do all this with AppsWorks. You can use it as a lifecycle tool to simplify management of application, reduce the number of deployment cycles. You can do all this with AppsWorks. Instance Manager, that's the one that has the wrong command. Okay, let's say that you want to patch 30 EC2 instances at once. Do you think, guys, that you can go there and patch one by one? No, you can use the Systems Manager, and with all the instances, you can manage. I mean, with all managed instances, you can patch or install or do any configuration changes to all the instances at once using Systems Manager. Okay. Systems Manager has a lot of things, right? Has a lot of things here. It has a lot of resources that you can use here. Okay. Systems Manager has one of the most important things in AWS is parameter stores. Parameter store is to store all the secrecy and the secrets, like credentials of a database, a specific information that is, super important. You can store here, but it is not the number one choice. It is number two. Number one is secrets manager. Okay, that's number one. So whenever you see a question that talks about or asks about storing credentials, and they give you secrets manager, and they give you parameter store in the same question, secrets manager is the answer. Okay, if you see parameter store and you don't see secrets manager anywhere, the answer is secrets parameter store. Okay, so the preferred way is AWS secrets manager. Second one is parameter store. Okay, very important, and that can be found in instance manager. Okay, right here. All right. So I have several parameters here. Okay, I can have an AMI over here. You see, I don't want anyone to know my AMI. I can put it in a parameter in the store, and then in the Cloudformation template, I can refer to this using the parameter section, and then I can point to the parameter store and bring this parameter, and then I'm going to get the value. Okay. So parameter store is very, very useful, super useful. Session manager, for example, if you want to start a session with a particular instance, I don't have an instance here, but you can start a session like when you SSH into an instance, you can do it in the session manager. Okay. AWS have been adding different resources here, features. Okay, before there was no hybrid activations. Now this one. So they have been making this much better. CloudWatch dashboard. Okay. By the way, a dashboard is a global service. It's a universal service. Okay. Now that I see it, it's very important that you know it. Okay. It doesn't matter in what region you have your EC2 instances. You can have a dashboard. You can have a dashboard of your EC2 instances in one spot. Okay. It doesn't matter what region your EC2 instance is. Okay. So you can add the widget, and then the widget can be any, you want to have it in lines, so you can choose this, and then you can have an EC2 instance, for example, per instance metrics, and then you can choose a specific instance, for example, this one, and create a widget. Okay, and have this particular metric here. Okay, so we can have several widgets here, and in one stop, this section here, we can have a good view of the health of your EC2 instances, no matter where they are created, no matter the region. Okay, this is a global, a universal service. All your instances, when you choose them, they're going to be here, regardless of their region. Okay, very good. That's the CloudWatch dashboard. Okay, I have this one here because I created it already. Toonie dashboard. All right, very good. So works across all the Windows and Linux workloads. This system manager runs in Amazon EC2 or on premises. Remember that the on premises instance starts with MI. The AWS instances start with I. Automatically collects software inventory. So we have something here, systems manager. We have something called inventory. It's right here, inventory. Okay, it's going to tell you all the resources that you have right now. So right now I don't have anything, but it's going to show you here the managed instance with inventory enable, inventory coverage per type, top 10 custom inventory types. So you can just set up inventory and see what you're gonna see. Select or manage instances in this account, specifying a tag, you know, depending on whatever you want, manually selecting the instance. I don't have any right now. Otherwise, they will show here all the instances are managed by system manager. Okay. So this is a pretty good service that is used for automation. Very good. You know, you can do tons of things with systems manager and at once. Okay, at once. So not one by one like EC2 or any other ES, not by one. What it does is it's just all at once. Okay, you can do all at once. Applies OS patches just in case you want to update your operating system. You can do it. Create system images. I'm sorry. Run command. We saw run command already. The run command, and what it does enables you to securely manage the configuration of your Amazon EC2 instances. Run command provides a simple way to automate common administrative tasks, such as executing shell scripts and commands on Linux, running PowerShell commands on Windows, installing software or patches, managing and sharing documents, allows you to execute commands across multiple instances, and offers visibility into the results. Okay, so we have this guy here, and then when you have run command, we saw it already, but you can have a document here. Okay, owner, you know, public documents. Okay, things that people have written already. Okay. Okay, let's see, for example, configure Docker. Okay, so the content is this. This is how you configure Docker. Okay, the versions, details. Okay, so these are documents. You can create your own documents. Okay, that's why when you go back and you see run command, and then you run command, there's one here that says owned by me, right? Owned by me, because you create your own documents. So how do you create your own document? You have to come here where it says documents, right? And then you can create a command or a session, right? So they are the ones that are owned by Amazon, things that are already created for you. So mine, I have this one that I created before, and what it does is it runs a shell command. Okay. Something that I did before. Okay. So you can get your own ones. Create a document here, you see? And then you can put the content here. You can simply delete this and create your content. Like for example, you wanna install Apache server. Remember when we install Apache server? We have to do this, remember? And then bash, and then you would do yum y update first, and then yum y install HTTPD, right? And then we say system ctl enable HTTPD, and then system ctl start HTTPD, and then let's say that you want to echo, for example, this. Okay. And you want to say something like, hi, how are you? Okay. And then we close H1 and we close HTML. Okay. And then we redirect this to var www.html.index. Okay. Okay, so in this case, it's not going to work fully because it has to be in JSON or YAML. Okay, So, but that's an idea for you to have an idea that you can create a script, right? And put it in this document, okay, and then run it. Okay. Right. So these are the documents that AWS has created for you guys. Configure CloudWatch. Okay, this is how you configure CloudWatch. Using JSON. So this is something for automation as well. So Amazon EC2 run command, Amazon EC2 run command enables you to securely manage the configuration of your Amazon EC2 instances. Run command provides a simple way to do that, okay? So a third-party automation options on EC2 instances. Launch and run any automation solutions on Amazon EC2, including Chef, Puppet, Ansible, and Salt. Okay, Chef and Puppet super popular. Ansible is super popular too. I've found some jobs, and when I read the description of the job, many of them mention Ansible. Okay, and Ansible is nothing else but a third-party automation service. Okay, that you can use in AWS. Okay, so maybe we can just type here Ansible, and then we can see the Ansible is an open source software provisioning, configuration management, and application deployment tool. It runs on many Unix-like systems and can configure both Unix-like systems as well as Microsoft Windows. It includes its own declarative language to describe system configurations. Okay? So people are learning all of this. Another one that is very popular is this one, Terraform. Super popular, that many companies are using it. Okay, when they ask you about your skills, they always ask you if you have any experience or have you ever worked with Terraform. Okay, so I would say that Terraform is the competition of Cloudformation. Okay, so many companies are using both, either Cloudformation or Terraform. Jenkins is a very popular building tool for building. Okay, many companies using it. AWS has integration with Jenkins. Okay, so integration with Kubernetes too, with Docker, with Puppet, with Chef, with Git. Okay, with Linux, of course, and all these guys with Salt. So AWS has been created to have a wide range of services integrated with it. So these solutions offer a variety of launch and configuration automation options. One-click deployment for Chef is available via the AWS Marketplace. Okay, let me see if I go here. And if I go to the Marketplace, and I need to have a subscription here. Maybe I'll come here to EC2 right here. So we'll come here. Maybe if I could, I don't think I can get this from here. I'm sorry, this. So we can get Chef here. Okay. Use the Chef Automate platform to package and test your applications, provision and update your infrastructure, and manage it all with compliance and security checks and dashboards that give you visibility into your entire stack. Okay, so Puppet as well, Puppet Enterprise, Ansible Control, CentOS 7, CentOS 8, Ansible with Ubuntu 18, CyberArk, Conjure, open source, Ansible AWX. So we have a different, flavors of Ansible here. You can find them in the Marketplace.
This will go as a software as a service, or
Which one?
the chef and
Oh, infrastructure as a code.
okay, Ansible for containers.
Yes. And Chef and Puppet, there are instances of OpsWorks.
Okay.
So the service is OpsWorks and Chef and Puppet. Red Hat, this is for Linux, Red Hat, Ansible, SaltStack. So these are providers that provide all this. So we click here. We have the Chef is the platform for automating your infrastructure on Amazon Web Services. Okay. Okay, so here we have these guys choosing the right solution, high-level services, which is this guy, right? And Maria, I think that this kind of answers your question.
Yes, very much so.
Yeah,
When I looked at it, I said, oh.
Here you do yourself, right? You have to
Mhm.
you have more control, but you have to do a lot of work because you have to create the template, you know, all that. This guy builds everything for you. You just upload the code. That's it. It knows what to create. It knows that it have to create last load balancer if you configure it.
Would it be fair to say that automation runs manual to automation runs right to left? In other words, manual on the right-hand side and more automated toward the left?
Yeah, makes sense, right? But like I said before, you have more control here, and then you start losing control until you don't have any more control, but it's more convenient. Okay, it'll be faster and faster and faster, and it's going to be more managed by AWS. Okay? The more you go to the left, the more control AWS takes.
And also costs will go higher, right?
Yes, 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 yes. An AWS Cloudformation doesn't cost anything. Okay, template doesn't cost anything, but the resources, they're gonna cost you more. I mean less. I'm sorry, because you decide what you build. So you're aware of the costs probably from the get-go. And also when you create, I show you guys when you create a stack, you can click on the estimate cost link, and it will tell you with a simple monthly calculator how much you will spend every month. With this guy, it's a platform. So you put the code there, and then you have no control over the infrastructure that's been built. Okay. And of course, Elastic Beanstalk is free too, right? And OpsWorks is free too. The services are free. These three guys, right? EC2 is not free, but these guys are free. What is not free is the resources that we create with them. Okay, so
it's a management then. It's not the cost, it's management of the resources.
correct.
Who I'm sorry, who does the management?
They're fully managed.
Yeah, from right to left,
From right to left.
Self to fully manage.
Yeah. So with AWS Cloudformation, you have some configurations to do, right? You have to create the template and everything. But once you create everything, I mean, you still have some control, right? Because you can go back to the template and update all that. Okay. But here you start losing control, right? You don't decide what instance is built, right? You don't decide what family type is built. Okay, you can configure later, but Beanstalk decides it for you. It depends on how big your code is. Okay, how much you need to build. Okay, but bottom line is that you start from here, like you said, Maria, and you start losing control, and you start losing less and less. You start going less and less manual as you go to the left. Okay. Like it says here, do yourself, high level services. Okay. So review the drawbacks of manual. We saw the drawbacks of manual. Okay, we see the anti-patterns. We saw the anti-patterns. The environment creation, explain the concept of infrastructure as code on AWS. Discuss the use of templates for automating resource creation. Review the automation resources and the convenience versus control of each tool. And this is what we saw in class, right? Do you guys have any questions before I go to the lab and explain the lab? Do you have any questions? A question whatsoever? So the lab that you guys are gonna do today is lab 5. Lab 5. So what are you gonna do in the lab? It's gonna be a pretty long lab. Okay. So first thing you have to do is start the lab. So this lab will require like 20 minutes to complete. Start, it all depends on how fast you do it. It may take you probably longer than that. Start lab. And then after, when the lab shows ready, there's gonna be a window that pops up, and then it starts giving you the status of the lab. When it says lab status ready, then you click on the AWS like any other lab. Okay. So the first thing you're gonna do is deploy a networking layer. Okay. So it is best practice recommendation to deploy infrastructure in layers, right? So you're gonna do some networking, database, an application, and each one is gonna have a different template. Okay. So that's the best practice, different layers, right? So you're gonna do right click here to download the template. You would need the template, right? To upload it in the Cloudformation console. Okay. So when you go to Cloudformation, you saw that already. You know how to get there. Every service is found here by clicking on services. Okay. And just typing the name of the service. So you're gonna create a stack, specify the template, upload a template, choose file. In this case, you're gonna do this one, which is the network one. So create lab, the stack name is gonna be lab-network. Then you click next, configure stack options, stack, the key is gonna be application, the value is gonna be inventory. We didn't use any tags, but you can use tags in Cloudformation. So we can continue, then you click next, review, and see that everything is okay. Then you click create stack. Then you click on the stack info tab. It's gonna give you all the stack, you know, it says, it's gonna say create complete, and everything, if everything goes well, it's gonna say create complete. If something goes wrong, it's gonna roll back. And you can click every 15 seconds or every interval, 5 seconds, 1 second, whatever. You can refresh to see if all the resources are being created. You can now examine the resources in the resource tab. You will see a list of resources, and then if the list is empty, click refresh to update the list. There should be something there. You can click on the event tab to see all the events that took place. Okay, so the list shows in reverse order the activities performed, you know, for Cloudformation is from the oldest to the youngest. Okay, and then you can see the outputs tab that you may see some IDs there to be used in another template. So a Cloudformation stack can provide output information such as an ID of a specific resources and links to resources. You will see two outputs, public subnet and VPC. So you see the ID of the VPC and the public subnet. Why is this important? Because if we want to create in another template, we want to create some EC2 instances, right? Like we said before, the network layer is going to be apart from the application layer. So if you want to use this, if you want to put our instance in this VPC inside this public subnet, I can import this ID from this template using the outputs tab, the outputs section in the template, and use it in the other template. So I don't have to create a VPC in the application layer. I can just import the IDs from the other template, okay? Which is pretty good, all right? So in the export name, we can see that. I'm gonna export the name of the VPC and the subnet and the ID as well. Now you can click on the template tab like we saw before and see the template that you created or that you downloaded. Okay? Task 2, deploy an application layer. You're gonna do exactly the same, right? Exactly the same. You're gonna download this guy. Okay. Let me see something here, one moment. Okay, let me show you something. Okay, let me just, okay, one moment. Okay, if I bring this here, right? This is the template of the application, right? So here, if you see, we're using, so this is the instance, right? Resource instances. Okay, we're using here, we are installing here an HTTP Apache server, right? In in the metadata. Here, let me see properties. You see the function here? Import value. Import value. You see here? We're bringing that subnet ID from the other template, from the template that we created, the VPC. Okay? So that's how you do it, right? And this, in the user data, we are installing the Apache server. Or actually, not Apache server, we're installing a Bootstrap something. So don't worry about that, okay? What you need to understand is that we're creating several instances here, several resources, and then we're using whatever was in the output from this layer is gonna be shown when we create these guys, okay? So we do the same process. We upload the template, we choose the file, we give it a name, lab application, the network stack name, because it's gonna be using another the other one, so it's a nested stack. Okay, so you click next. We're gonna use a key. It's important to know for tagging. It's super important. Okay. So we're gonna click on next, review the network, create the stack, and then wait for the stack status to change, okay? So application now ready. So click the outputs, and then we're gonna have a URL, right? When you click on the URL, you're gonna be able to see what is displayed there. Why? Because in this template, down here, if you go down, we have the output section. And then the value is gonna be the web server instance.public DNS name, okay? Whenever you create an instance, the instance has a public IP and also has a DNS name. So we are grabbing that DNS name and we're showing it in the outputs, okay? In the outputs of that template. And then you can click on that URL. And what happens is that it's gonna display whatever we install inside that server. Okay. So we hear a server security group. We importing the VPC ID. Okay. And the subnet ID, we are importing the subnet ID. Okay. So this is going to be in the output of that of the network layer, and then we import it in the application layer. Now we update the stack. We want to make some changes here. Okay. So we go same process, select web server security group, click the inbound tab, and then you will see that there's a current only one rule in the security group, which permits HTTP traffic. You will now return to the Cloudformation to update the stack. On the service, go ahead again and add this, okay? Like we did in our template, okay? This guy, we're gonna add another one. And the one that we're gonna add is the one that is for 22. Or actually, yes. Okay, so you click on lab application, update, replace current template. We saw that already. I did it for you guys. I'll load the template, click next 3 times to advance to the review page. Why 3 times? Because in between, there's nothing to change. There's nothing to touch there. In the change set preview section at the bottom of the page, Cloudformation will display what resources need to be updated. Okay, let's say that I want to, real quick, I want to add another CIDR here. Let's say that I want to do this, right? Okay, and I want to, you know, put here 3306, okay, and 3306. Okay, so I'm adding another CIDR. And then this guy is, I'm going to move it to the right. To be in line with this guy's here. Okay. So if I update now my stack in Cloudformation, you're not here anymore. Cloudformation, and then in Cloudformation, I create a stack. No, I'm not create a stack. What I do is I update this stack. Okay, and then replace current, and then I come here and say Cloudformation template, and then I do next. Okay, I'm gonna change now to micro. Okay, and then I go here and do next all the time. So if I just wait a little bit, you see, it's gonna change. It's gonna modify my instance because I changed the type, and it's gonna add the CIDR, the new CIDR to the security group. It says false here. It's not gonna replace it. It's gonna modify it. And this depends, right? It's conditional. Depends on whatever I have there. So the change sets, the change section here, which you will see in your lab, right? Where's your lab? Oh, it's right here. Workbench. Here, you can see here, whatever is being modified or anything. All right. So you update the stack, you explore the template, you can see, go to the designer, right? Like we saw before. Okay. Saw before. Remember when you come here, we create the stack. And then here, the template, we can see the designer, right? I added another CIDR here. You see, another CIDR, and then I can see that in the designer. Okay. So we continue here, and then finally, when we're done, we delete the stack because we don't want to be charged. Well, in this case, you're not going to be charged by it. You know, it's a good practice to delete everything after you have finished using it. Okay, so even though this lab is going to disappear when you close it, still AWS gives you the option to delete it for you to, you know, develop this into a habit of deleting whatever you're not needing anymore. Okay, so once you do that, the lab is complete. I hope you understood my explanation about the lab. I don't think it's anything new that I haven't said in class. I spoke about everything that you're gonna do in the lab. The only thing that I didn't demonstrate was the import and export, the output section, but I talked about it, and you guys now know the purpose of the output section. Okay. Okay, so maybe, yeah. Do you have any questions, guys? Any questions whatsoever? No questions?
Professor, I have one question. In my lab 3, task 2, I couldn't upload the file. I couldn't download the file. They didn't give me option for that. And when I tried to download it, they
Which
did
one?
tell me like they cannot. It was
Which one?
lab 3, task 2.
Oh, this one? The
Yeah,
application?
and then
Okay.
when you need to download the file.
Okay, good. I can Slack it. I just downloaded it. Okay.
So I wasn't able to complete the task because of that.
Okay. Okay. So let me show you here. Let me give you I downloaded it, just downloaded it. And okay, so I'm gonna put it, I don't know if I can put it here in the chat. I don't know if I can, yes, it has a file section here. Maybe if I can probably out of here. No, I can't.
This lab you will put in the classroom?
Yes, yes. Okay.
After the class, right?
Yes. So the name is lab, right? It's right here.
Lab 5.
Okay, it's right there. The lab is there, Olivera.
Thank you so much.
So you can download it, showing finder, whatever. See guys, we can download it from there.
It should be in the chat. I don't see the.
It should be in the chat, right? So I'm gonna stop the live streaming now, and if you have any questions, I'll still be here.